Welcome to this video. My name is Darshan M.Katgeri. I am working with Jain College of Engineering, Belgaum. In this video, we are going to talk about problems on pentagonal pyramids. Especially the pyramids, they are going to rest on triangular face. We are going to solve two problems. One is by using the direct method and one is by using the locus method. When to use which methods, that we will discuss when we are going through the problems. So the first problem reads like this: the pentagonal pyramid, 25 mm sides of the base, and the axis length is 50 millimeters, and it is resting on one of its slant triangular faces. That means it is resting on a triangular face, and we have to draw the projections of the pyramid when the axis appears, this is again important, appears to be inclined to VP at 45 degrees. So let me just show you the visualization once. So this is the pentagonal pyramid. It is a pentagonal pyramid because its base is a pentagon. It has been named as ABCD. Let me just show you the top view of this. Yes, ABCDE. And to spot the center, you have to bisect the sides. Say, for example, you bisect AB and BC. Wherever the perpendicular bisectors intersect, that point is the center of the pentagon, which is required. Let's go back to the presentation. Let us start this. As usual, start with drawing the XY line, named VP and HP, and draw the pentagon. It has to be drawn like this. Now, because it is going to rest on an edge, it's going to rest on a triangular face, the orientation of this pentagon has to be like this. What it means is, when we place it like this and when we rotate this, let me just rotate this and show you. Just give me 1 second. When we rotate this, and we have to rotate it until the triangular face, in this case the yellow face, is going to rest on the vertical plane. Okay? So this is what we are supposed to do. Let us go back to the presentation. So that is why we need a triangular face on this particular side. So that is why the pentagon has to be drawn like this. And the center of the pentagon has to be obtained by bisecting the two sides. One more way to obtain the center is join the corner to the opposite midpoint. Like, for example, corner A has to be joined to the opposite midpoint. The opposite edge is CD, and you can join the corner B with the opposite edge, that the midpoint of the opposite edge. So wherever those two lines meet, that also will be the center. So you can use any of the two methods to obtain the center. So once you obtain the top view, dimension it and name it as shown in the figure. Next, take the projectors, mark the axis, and draw the front view as it is shown in this. Dimension the axis. The axis length is 50 mm in this case. Join this slant edge, join this slant edge, join this slant edge, and join the base and name it accordingly. Observe that point B dash is put in bracket because it is behind, so it cannot be seen, and C dash is also put in bracket because it is behind, it cannot be seen. As in this visualization, you can see that there are points. Point B dash, this is the point B dash, which is behind. So we are seeing from here, this point is behind, it cannot be seen, and also point C is behind this point, so this also cannot be seen. So what is seen is this particular face, this particular view. So we have drawn this. Next is we have to now make it rest on one of its triangular faces. That means we have to make this face, that is O1 dash C dash D dash, lie on the XY line. So we go back to the presentation here. That means we are supposed to draw this particular view. You can see that it is now going to rest on one of its triangular faces. See this face, O2, sorry, O2, D, and this is C. This point is C. So it is going to lie on this particular face. So to get this particular view, you mark one point at a convenient distance, name that point as C dash D dash, that is going to represent this particular point. Then measure C dash D dash and O1 dash. You measure this and you mark it here. And you can measure the distance from C dash D dash to A dash and mark an arc. Next measure A dash O1 dash, and from this point is O1 dash, you cut an arc. The two arcs will intersect. That point is point A dash. That point is point A dash, and you join all the points. Then you measure the points C dash D dash, B dash E dash, and you mark this, and you mark point O2 dash, which represents the axis. All of these have to be done by using the compass and by drawing the arcs, and you can name them accordingly. Be very careful when naming. Next, we have to draw the projectors, the vertical projectors and the horizontal projectors, and name them accordingly. Observe that point A is here. Okay? So we have to be careful. Point A is here, and this represents the edge. The next thing is to visualize. Let us go back to the software. If I see the top view, you can see that the base is completely visible. The base is completely visible in this case, and also the triangular face, that is this triangular face and this triangular face, they are visible to us. And there are three triangular faces that are not visible to us. So that is, this is one, this is in purple color. This is the first one, and the triangular face on which it is resting is also not visible, and another purple face is also not visible to us in the top view. This will be more clear in this particular mode. The base is completely visible, and the triangular faces, that is these two, that is in this cyan color, they are completely visible to us. Now we have to spot the same in this view. So how to do that, I will explain. The first thing that we can do is join the boundary lines. Always join the boundary lines. Boundary lines will always be visible. Like for example, in this case, we have to join CB, BO1, O1E, EB, and BC. Next, we see that A is the A dash in this view. A dash is the nearest point. Spot the corresponding point here. So that point is here, A. Whatever is going to start from this point, in the sense the nearest point, observer will be here. So this will be the nearest point. Whatever is going to start from here is going to be visible. So what is going to start from point A? For that, we will come to this view and see lines AB, AE, and AO1 are going to start from point A. So AB, AE, and AO1 are going to start from point A, and which have been shown here. Also see that C dash D dash is the farthest edge. So if you observe from here, this is the farthest edge. This is drawn continuous because it is the boundary line. The other lines will not be visible, so they will be shown by hidden lines, dashed lines, you can say. So they are represented here. So this is how we have to identify the hidden faces. Next, we have to decide whether this has to be solved by direct method or we have to solve this by locus method. Let us see how to do that. For this, we have to very carefully read the problem. It is given that when the axis appears to be inclined to VP, that means the apparent inclination is given in this case. And in this view, that is the apparent top view, we have the apparent length of the axis. This is with respect to the axis, right? So the apparent inclination is given and apparent length of the axis is available. So this has to be solved by direct method. So draw a line at 45 degrees and reconstruct this. Reconstruction I have explained in the previous videos. Mark point O1, mark this point O1 and measure O2 and mark this point O2 by drawing an arc using compass. And with respect to these points, you can get all other points. So O1B, you measure O1B and mark here. At the same time, you can mark O1E also, mark O1E. Then O2B, you measure O2B using a compass, and from here you mark O2B, and at the same time you can mark this point also. Then you can take O1C, mark this point and this point simultaneously, and O2C and mark O2C on this side and on this side as well. And you have to join all the points. You will see that there is no change in the appearance of the view. The axis is only inclined at 45 degrees. Name it. And now we have to obtain the final front view, for which we have to take all the projectors, vertical projectors and horizontal projectors. Just to get the view and try to explain. Yes. So spot all the points here, draw the projectors and get all the points and draw the boundary lines. Boundary lines are always going to be visible, so you join all the boundary lines. Now observe that in this problem the base is towards the observer and the apex is towards the vertical plane, so the base is visible to us. Okay? So the base is going to be visible to us. Okay, also one more way of identifying would be spot the nearest point. In this case, E is the nearest point. When you see from here, E is the nearest point. So whatever is going to start from point E dash here is going to be visible to us. What is going to start from point E? ED, EA and EO1. So E in this view it will be E dash D dash, E dash A dash and E dash O1 dash. So join all the points. We have already joined the points A dash E dash and E dash O1 dash because they are the boundary lines. The only line remaining was E dash D dash, which has to be drawn as a continuous line. And you will observe that B is the farthest point. So that point is B dash in this particular view. So whatever is going to start from B dash will be hidden, but boundary lines are always visible. You must always remember that. So we will just see what is starting from B, BA, BC and BO1. So BA and BC are already drawn because they are the boundary lines. Only line remaining is this BO1, that is B dash O1 dash in this view, and that will be hidden. Also take note that all of these triangular faces are behind. They are behind the base like this. Okay? So most there are triangular faces here. So you can see that this face is not visible. This face is not visible to us, and the base on which it is resting is also not visible. So this is the view that we have drawn. So you can just relate it to this. This is the view that we have drawn. If I just put on the X-ray mode, we can see this. Let us go back to the presentation. So this is the complete solution for this problem. This problem may be solved on the grid sheets. Let us go for the next problem. This problem is similar to what we have done. The first steps are going to be similar. The only thing is that the final views, we have to decide on whether to use locus method or direct method. So we will quickly go through this, draw the view, obtain the center, join the slant edges, take the projectors and get the front view, initial front view, then reconstruct this such that C dash D dash O1 dash lies on XY line, and take the projectors, name them, there's absolutely no change till here. Now we have to read the problem carefully. Now here you see that it is given when the axis is inclined, given that it is inclined to VP at 45 degrees. That means the true inclination is given to us. The true inclination is given and we have the apparent length of the axis. So to plot this apparent length, we need apparent inclination. So we have to obtain the apparent inclination. In order to obtain the apparent inclination, we have to solve this problem by locus method. What is this locus method? I will explain. Measure O1 dash, O2 dash, that is the actual length or the true length, and mark one point here and let that point be O1 dash. From that point you mark O2 dash. So this is the axis length, that is the true length of the axis. Then from you draw an arc. Wherever the arc cuts this 45-degree line, you draw one line parallel to XY line. That is the locus. Next point is you measure O1, O2 from this apparent top view, and from the point O1 you cut another arc on this locus and you join this arc to O1 dash. Wherever it has cut the locus line, that point, let it go through O1 and you extend this back and it makes a certain angle with XY line. That is nothing but the apparent inclination. And from now on the problem will again be very similar. The reconstruction has to be done on the apparent inclination line and not on 45-degree line. In this case, that is the only difference. And you reconstruct all of this. The reconstruction has been explained in previous problem. Obtain all the points and obtain this view. Here you can see that there is only a slight change in this face. So the not notable, but little change is there in this particular view. There is no difference in solving the problem. So this is the complete solution of the problem. This problem can also be solved on the grid sheets. Thank you.